Thank you, everyone. I've got to say, before I even kick off, this is just a wonderful site. I've given so many talks over the past couple of years, just staring at a camera lens, and it's just so beautiful to see all of you come out here and engage as a community. So thank you so much for everyone that's made this possible. Thank you for everyone that's here. Really appreciate it. My name is Rob Barnes, also known as DevOps Rob. I'm a developer advocate at HashiCorp. And today I want to talk to you about how you can use your cloud identities to authenticate to HashiCorp Vault. Right. So in terms of identity, that's something I spend a lot of my time thinking about. We have so many different cloud providers, we have so many different platforms. A lot of these things boast their own identities. How do we use that to get to a common plane to deal with our secrets management? So that's pretty much what I want to talk to you today about. So let's look at the problem a little bit, right? So I'm not sure how far people are along in their kind of secrets management journey. So we're going to kick it back to basics just to kind of fill in all the gaps here. So here we have kind of a simulation of a few apps or microservices, whatever you want to call them, and each of them need to connect to different databases and so on and so forth, right? So the challenge here is, how does each application authenticate to each of these databases? It could also be a message queue. It could be any other piece of infrastructure that it needs to interact with in order to perform its function, right? And typically, what we were doing pretty wrongly back in the day was we were hard coding credentials for databases, in this example, in our code. Very bad practice, right? So, if anyone could get access to the source code, or if anyone could get access to any of that kind of stuff there, then essentially you're giving them just free access to all of the data inside your database. GDPR will have a problem with that. I think everyone knows that, right? So we move along a little bit, right? We want to get into this whole zero trust thing. I know it's the buzzword and defense in depth. This is what everyone's talking about. But we want to move away from something like this, and we want to move into secrets management, right? So if it changes, instead what we do is we bring in a secrets management platform, right? And the idea here is, if you want to do something that's zero trust, there's a couple of things that you want to centralize, and secrets management platform is one of them, and ideally identity is the other thing, right? So instead of these applications just possessing the credentials to speak to their respective databases and so on and so forth, instead, what they do is they go and speak to a centralized secrets management platform. So in this case, we've got HashiCorp Vault. And they say, hey, I'm app one. Can I have some credentials to speak to this database up here, for example? And Vault will turn around and say, absolutely, here are the credentials. And it will be, in this case, something we call ephemeral. So essentially, it will give you a short-lived credential. And once that TTL has expired, Vault will then go away and clean up that credential. So, it limits the blast radius, right? So, job done, right? Problem is solved. Well, the thing is, we're now in this situation. Applications had credentials to get to these databases before, right? Now, they need to speak to this centralized secrets management platform. So are we not in the same situation where you're now, instead of putting database credentials in your application code, you're now having to put HashiCorp Vault credentials in your application code, right? So we call this secret zero, right? It's very much a big problem in the security industry. How do we securely introduce secret zero into our applications and our workflows, right? So if we look at applications and we compare it to humans, in my opinion, the human side of things is very much a solved problem, right? So you have your centralized identity providers, so it could be Active Directory or whatever you're using as an identity provider. And we can use that through methods like OIDC to authenticate to other services. So as long as you set up that relationship between your identity provider and the target platform, you can use that. Now, why does that work for us as human beings? It's because we know something. We know a unique piece of information, a password, for example, and we can use that to authenticate to our identity provider, who will then attest to our target platform that, yes, we are exactly who we say we are. I am Rob Barnes. For machines, The same problem exists, but essentially for them to know that piece of information, we're going back to square one where we're giving the application that piece of information. Makes things a bit tricky, because now anyone that has access to it has the same problem. Like they can access data that they probably shouldn't do. And we try to apply the principle of least privilege. So if you don't need to know a piece of information to perform your function, you should not know it, right? So that's the challenge. Secret zero introduction. How can we solve it? Before I continue, just formally introduce myself. I am Rob Barnes, also known as DevOps Rob. Working for HashiCorp, I mainly focus on the secure product line. So Vault was why I came into the business. We also have HashiCorp Boundary as well, which is a session management tool. I can talk about that in another talk. I know some people that I've spoken to in the audience have expressed some interest in hearing about that, so I'll be glad to come back and speak about that. But primarily, I go where there's any kind of security that needs to be injected into a workflow, and that's what interests me, right? So let's crack on. So we're talking about cloud identities, right? So a lot of people are in the cloud at the moment. And most cloud providers out there have some form of identity that they can assign to workloads. So what do we mean by a workload? It could be a system, it could be a VM, it could be a Kubernetes pod, it could be a serverless application. Any kind of workload that is performing a function, that's basically what we're calling a workload, right? And cloud providers are giving us ways to assign identity to these things. Now, how can we take advantage of these identities? I'm going to use Azure as an example, right? So Azure has the concept of managed identities. We have a gentleman here, can't see him over there, from AWS. I know AWS has a similar construct, GCP, just pretty much all of them have their own identities. Azure is managed identities, and you can assign this to pretty much any workload within Azure, right? Now, how does that help us get closer to the problem? Well, each of these applications have their identities, right? And instead of having to give them a password or some kind of secret information that's in the source code, it's baked into the actual infrastructure or into the actual workload itself. And what it's doing is it's going to Vault and saying, hey, this is my secure piece of information. Can I exchange it for a Vault token? Which is the core construct in HashiCorp Vault. No matter what method of authentication you use, it's always going to exchange itself for a Vault token. So speaking specifically about managed identities here, the auth method we're considering here for HashiCorp Vault is what we call the Azure auth method. So essentially, it's just taking some key pieces of information from the infrastructure and it's exchanging that for that Vault token. So this is just a screenshot of the Azure portal. So essentially, this is just a VM. I've just spun up a VM because it was just nice and easy to demonstrate this. But there's an identity tab on here, and you can literally just flick that on, and it assigns it an identity, right? Now, you have two types of identities in Azure. You have system assigned, which is what you see right here, and you have user assigned. The main difference between the two, a system assigned, the life cycle is tied to this piece of infrastructure. So if I burn this VM down, the identity goes down with it. With user assigned, it's an identity I'm actually creating myself. It's another cloud resource. And what I can do is I can attach that identity to one or many pieces of infrastructure, right? There are different use cases why you would choose that. But the thing is, when you burn the infrastructure, it does not take the identity down with it. You're responsible for removing that identity once it becomes obsolete, right? So, this is just the portal way of doing it. I work for HashiCorp. Terraform is probably a better way to deploy and manage your infrastructure. You can apply all of these identities to all of your infrastructure using Terraform as well. The resources are there for most of the cloud providers. And the next thing I'll introduce you to is instance metadata service, right? So this is a feature of Microsoft Azure, which is pretty cool. Essentially, on the VM itself or on the workload, you can make API calls to a local endpoint, which is only accessible from that workload itself. So no one else can come in and get it. And you can access different pieces of information. You can access the resource group, the name of the VM, or just whatever it is. So it's just pretty much any metadata associated with that piece of infrastructure, right? In the same way, when we talk about managed identities, it's the same thing. You can make a local API call to a local endpoint to obtain like a JWT or a JOT. How are people actually saying that? Let's clear this up one. JOT, thank you. So JOT, so I've been educated, so I'm no longer going to say JWT. So you can make this local call, you can get this piece of information combined with some pieces of metadata that you need, and you can go to HashiCorp Vault and say, hey, this is who I am, this is how I can prove it, can I get a Vault token? And it will exchange it for that, right? So, may the demo gods be with me. I'm not gonna lie to you. I probably built about 3 demos in the last week, and all of them have gone horribly wrong. So what I did today was I pushed my code. I tested it, I built it, I pushed it. It's there in the cloud right now, so the hard bit's actually done. I said my prayers, but I don't really trust the demo god. But anyway, we move. So let's move over to my terminal. We'll just mirror the display for a second, and we'll head over here, right? So can everyone see that? Would you like me to boost the size? In fact, I'll just boost the size. Right, okay. So we have a piece of infrastructure in Azure, right? We have a VM. You can see I'm already SSH'd onto the VM, right? And essentially, what we want to do is we want to get this piece of information from the VM itself, and we want to go to HashiCorp Vault and exchange it for the token, right? Now, Vault is running. Has anyone heard of HCP or HashiCorp Cloud Platform? Anyone up on that? There's a couple of nods. Good. So I'm running my Vault on HCP just because I can't be bothered to run my own infrastructure. Why? Then HashiCorp will do it for me. So if you've never seen that, I'll probably show it towards the end of this, right? So essentially, we just want to make an API call. So what I'll do is I'll do it in Bash to start off with, just to kind of show you the workflow, and then I'll just show you a Go application I've written, which does the same thing, right? So where are we? CLI example, give me a sec. Oh, what has happened there? See? See what I mean about the demo gods? We try again. Let's clear it up. Matter of fact, what I will do, which it shouldn't have done that, is I'll just open up a new tab just so we can explore the command, right? So this is just the Vault CLI, to be honest with you. Everything you do in Vault is API driven. So the CLI is just kind of an interface on top of that, right? So we're looking for a few pieces of information. So we're looking for the JOT is how we've agreed we're going to say it, right? We're looking for the JOT. So we're making an API call to the local VM, just to this endpoint here, and we're obtaining that, and we're just placing it inside a variable. We're also looking for the Azure subscription ID, and we're looking for the resource group name and the VM name, right? So a combination of these 4 pieces of information should give us a Vault token, right? Now let me just clear this and see if the demo gods are going to be with me this time, because this has worked 1,000 times and all of a sudden it's not working, right? So we'll try again. And it's not working. Why is that? What has changed? Something has changed. We're not going to get into that. It normally works. I've messed up something somewhere, right? So let's just look at a Go application, which should work, because this is the part that I pushed. If that doesn't work, I'm going to scream. So if we look at this Go application, the first thing I'll do is I'll take you through the models, right? So let's just bring this down a little bit. So there's a few pieces of data structure that we put in there. So if you program in any other language, a struct in Go is pretty much just like a class in any other language. So if we're talking about the data structure for the managed identity, this struct here is the pieces of information that we can expect back when we make that API call to Azure, right? So we just laid out the data structure so that when we make the API call, we can marshal it into this structure, or unmarshal it, should I say, into this structure. And then we go into the instance metadata service. So there's a couple of API calls we're making here, and we've broken it down into just the way that the format that the JSON comes back in, right? So we just have a few pieces of information, the subscription ID, the name, the resource group, and we have some compute-specific pieces of information which all link. And then the final pieces are the actual Vault tokens. So when we make the API call to Vault to authenticate, we literally have these two structs here, which are intertwined to give us the Vault token, right? So that's pretty much the data structures. In total, we are going to make 3 API calls, right? 2 of them are locally within the Azure VM. So let's have a look at the managed identity one. I'm not going to go through this. I'm just making a point that you have an endpoint here, and you're just making an API call to that. Anyone that's programmed in Go knows how you use this library to make API calls. So essentially, this is you getting the JUT token. Let's get that right, the JUT token, right? Next API call we're going to want to make is to the instance metadata service, which gives us a series of information. Same thing, same process. We're just making an API call, whatever language you speak, or you write in, shall I say, you would just do it in your language. It's all API driven. And finally, with these pieces of information, we make our third and final API call, which is to Vault. And essentially, there's a few things I want to point out here. So the way I've written the application is we need to give this application a few pieces of information for it to work, right? So we need to know where Vault is. What is the endpoint for Vault? So we just do that via environment variable. So the application looks for this environment variable. If it's not set, it will fail. That's fine. The second thing is the Azure auth method. The way it works is you configure this auth method and you assign roles to this auth method. Now, all that role is doing is pretty much saying that anyone that signs in with this role can do these things. It's basically like an authorization package, if you like, right? So we want to know, when you authenticate, what Vault role are we using to log in, right? And because we're on HCP Vault, everything is namespaced. It's using the enterprise version of it. So we need to know what the Vault namespace is. So we're just looking for these environment variables here. We're just doing some check-in to make sure they exist. And the same thing, we're making an API call to this endpoint here. And we should get a token back. So let's try again, demo gods. Hopefully it works. So the first thing I need to do is set those environment variables in order for it to work. So let's try this here. Well, that worked. Fantastic. Okay, so we set these environment variables. Now, like I said, because I don't trust the demo gods, I built this application and I pushed it to the VM in advance because that would be pretty awkward. So I'm just going to run this, and what should happen is we should get a Vault token back, right? And we do. There's a Vault token, right? So let's just try and log in. Thank you. I love this crowd. The demo gods, thank you too, right? So what we'll do is I'll just copy this token, and we'll just try and log in and just see what we can get with that, right? So if I do a Vault, pebcap, problem exists between keyboard and chair. Oh. And then we'll just pop in that token there. And we're logged in now, right? So if I were to do a Vault token lookup, so we can just look up something about ourselves, it gives us these pieces of information here. The reason why I'm doing a lookup and not anything fancy is because I haven't assigned any permissions to the role to go and look at some secret stuff, right? Had I done that, had I written a policy, had I had some secrets that I wanted to view, then we could have gone and looked at a secret or asked for a database credential or something like that, right? So the point of this application is just to demonstrate how you can just use simple API calls. And I think everyone that deals with applications is quite comfortable making API calls just to authenticate with a centralized secrets management platform. There is no secrets in your code or anything like that. The only secret material is on the actual piece of infrastructure. It's all contained within that infrastructure and cannot be accessed from anywhere else, and that's on the cloud provider. And essentially, there are probably better ways to write this application. I'm not the best developer. You probably want to get this token, and you want to store it somewhere that the actual application that's doing the function can access it. You don't want it to have to keep making API calls every time it's performing its function. But that's not the point here. The point is, you've seen the workflow, you can get creative and see how does it fit into your workflows, right? So let me just flick back to my presentation. And right, so I have a quick recap. We've looked at the secret zero challenge, right? This is a real problem. I literally spend most of my days sitting there thinking, how do we assign identity to applications, right? Now, I showed you an Azure example, but what if pieces of your application are in Azure and other pieces are in AWS? How do you go through that whole translation piece of identity? I don't really think that's a solved problem at the moment. And I scratch my head trying to think of ways to move us forward. I run a podcast, actually, talking about these things called Keeping It Secure. You should check it out. We've looked at the Azure auth method. We have plenty of auth methods out there. So this is Azure we've done. It could easily have been Kubernetes. Instead of using the managed identity in Azure, it could be a service account in Kubernetes, which is its native identity construct. It could be AWS, their identity, whatever it is, right? It doesn't matter what your platform is. You can pretty much just take this workflow and swap out the pieces so it fits for you, right? It works the same way. Obviously, we've looked at managed identity itself, and we've looked at the instance metadata service, and we've looked at, in combination, how can we use these things to authenticate without having our code insecure. Finally, I'll just leave it there. I really enjoyed your talk, I'm so glad you gave that talk, because I've put my YouTube channel up there because I actually make a lot of content about the things that you talked about. I have a lot of opinions, a lot of things that you said that I really agree with. So yeah, I mean, if you're interested in that kind of stuff, please feel free to head over to youtube.com/DevOpsRob and give me a subscribe and just check out the content and leave your comments and engage. And other than that, I'd like to thank you and bid you good evening.